Welcome to this explainer. Today, we're taking a completely physical journey, literally building a PC from the inside out. Now, if you're gearing up for the CompTIA A Core 1 exam, specifically the 220-1201 version, you already know it's just packed with acronyms, connection types, and a ton of hardware specs. But hey, instead of just staring at a textbook trying to memorize all that, we're going to master this hardware by seeing how it all connects together in the real world. So get ready, because we are going to conquer Domain 3.
So why are we focusing so heavily on this? Well, it's because Domain 3, hardware, accounts for a massive 25% of your entire Core 1 exam. Think about that. That's a full quarter of the test riding on your understanding of these physical components. Mastering this domain is absolutely crucial for test day, and honestly, getting this right is going to be the bedrock of your entire IT support career.
Okay, let's dive right into this and look at our agenda. We're breaking this domain down into 4 easy buckets. First, motherboards, CPUs, and cooling. Second, memory and storage. Third, cables and power. And finally, printers and peripherals.
All right, starting things off with Section 1, motherboards, CPUs, and cooling. If you think of a computer like a human body, the motherboard is your central nervous system. These come in standard form factors, which is just a fancy way of saying sizes. ATX is your standard, large desktop board, moving down to microATX, and then the highly compact ITX. Now for the brain of the operation, the CPU. You've got your traditional x86 and x64 architectures, but right now, the industry is seeing a massive shift toward ARM architecture. Why? Because it's incredibly power efficient, which drastically prolongs battery life, and that's exactly why it absolutely dominates mobile devices. Now, to connect that brain to the nervous system, you use a socket. Keep this in mind for the exam. Intel typically uses LGA sockets, where the pins are actually on the motherboard, while AMD has historically used PGA and AM sockets, where the pins are on the processor itself. Now, all of that processing power creates a major byproduct, and that's serious heat. Here's where I want to put on my coach hat for a second. If you get a scenario where a user says their computer fans are suddenly spinning at maximum speed and the machine just shuts down after 5 minutes, well, your CPU is overheating. To save its own life, the processor uses something called thermal throttling. It automatically slows itself down to prevent physical melting and damage. To stop this from happening, we rely on active cooling, like system fans, and passive cooling, like metal heat sinks. And don't forget the thermal paste that bridges any microscopic gaps between the CPU and the sink. Keep that CPU cool, or the whole system literally dies.
Moving right along to Section 2, memory and storage.
Think of your system as a workspace. Memory, or RAM, is your short-term working desk, while storage is the long-term filing cabinet sitting over in the corner of the room. When you're picking out that desk space, you're going to encounter 2 main types of RAM. First up is ECC, which stands for Error-Correcting Code. This is heavy-duty, server-grade hardware that detects and actually corrects data corruption on the fly to prevent system crashes. It's incredibly stable, but a little bit slower. Then you have non-ECC RAM. That's what you'll find in standard consumer desktops and laptops. It skips the error correction altogether to favor faster speeds and much lower costs.
And you know, speaking of laptops, you absolutely have to know your form factors. Standard desktop motherboards use full-size DIMM slots, but when you're dealing with the tight, compact chassis of a laptop, you use SODIMM, that small outline dual inline memory module. It's essentially just a physically shorter stick of RAM. Being able to quickly distinguish between a desktop DIMM and a laptop SODIMM is a super common mobile hardware specification, and you'll definitely need to recognize it on the exam.
Now let's talk about that long-term filing cabinet. And this really brilliantly illustrates the massive leap in technology we've seen in recent years. Hard disk drives, or HDDs, use older physical spinning magnetic platters, usually spinning at about 5,400 or 7,200 RPM. They are super cheap for massive amounts of storage, but physically, they're pretty slow. Contrast that with modern solid-state drives, or SSDs, specifically M.2 form factor SSDs utilizing the PCIe NVMe interface. These guys have absolutely no moving parts and offer blazing fast, direct-to-motherboard data transfer speeds that just leave traditional hard drives completely in the dust.
Sometimes, though, one drive just isn't enough, so we combine them using RAID. I'm going to slow the pacing down a bit to walk through this because CompTIA absolutely loves testing on RAID configurations. Okay, so RAID 0 is striping. It gives you great speed, but 0 redundancy. If one drive dies, you lose the whole shebang. RAID 1 is mirroring. That's an exact duplicate of your data for safety. Then there's RAID 5. This one requires at least 3 drives and uses striping plus a parity bit. So the crucial takeaway here is, if you get an exam question mentioning a server displaying an amber light on a single drive in a RAID 5 array, it means that specific drive is dead. The system is slowing down to rebuild the missing data using that parity bit. You just replace the failing drive to initiate the rebuild. And finally, RAID 10, which beautifully combines the speed of striping with the safety of mirroring.
All right, let's shift gears to Section 3, Cables and Power.
Think of these as the arteries of our computer, pushing electricity in and pumping data out to our displays and peripherals. You really have to know your connectors on site. For displays, you've got the older analog VGA, moving up to high-definition HDMI and DisplayPort. For data, you have various generations of USB, peaking with the modern reversible USB-C right alongside Apple's proprietary Lightning cable. But pay special attention to Thunderbolt. Often sharing that exact same physical USB-C port, Thunderbolt is special because it can carry both incredibly high-quality video and blisteringly fast data at the exact same time. It's a true powerhouse of a cable.
Now, what's really interesting here is how we can actually use data cables to solve physical power problems. Imagine you need to install a security camera way up high in a drop ceiling, or maybe an access point down a long hallway. There are no electrical wall outlets up there. Well, Power over Ethernet, or PoE, solves this by injecting electrical power directly through the standard network cable using a PoE switch. So, one single cable provides both the network connection and the electricity. Pretty brilliant, right?
Since we just mentioned drop ceilings, here is a massive coach hint for you. Literally, write this down. If an exam question ever mentions running any type of cable, whether it's Ethernet, coax, or fiber, in the space above a drop ceiling or inside an HVAC air circulation system, the answer is always 100% of the time plenum-rated cable. That plenum space is where air circulates throughout the building, and normal cable jackets actually release deadly toxic gas when they burn. Plenum-rated cable is specially fire-rated to prevent this. Of course, providing power to all the internal components relies on the power supply unit, or PSU. When you're picking a PSU, getting a modular unit allows you to only plug in the specific cables you actually need. This greatly reduces internal case clutter and really improves your cooling airflow. Also, if you're deploying desktop PCs globally, always look for a manual 110-volt to 220-volt input switch on the back of the PSU so you don't blow the entire system when plugging it into a European wall outlet. Oh, and if a system ever randomly shuts down, you can actually test the PSU's 12-volt and 5-volt rails directly using a handy hardware multimeter. And that brings us to our final stop, Section 4, Printers and Peripherals. You know, a lot of test takers completely underestimate printers. So let's do a quick micro-challenge to test your troubleshooting instincts. Imagine a user prints a document from a laser printer. But when they pick up the page, the text physically smudges and wipes right off the paper onto their fingers. The toner is there, but it's just not sticking. What internal component has failed? Think fast.
If you guessed the fuser assembly, you hit the nail on the head. In a laser printer, toner is basically just a really fine plastic powder. It gets placed on the paper, but it has to be permanently attached. The fuser assembly uses intense heat and pressure to literally melt that toner directly into the fibers of the paper. If the fuser is broken, well, the toner just sits there as loose powder on the page and wipes right away. Let's see how this all builds into the overall maintenance life cycle, because printer paper jams and smudges are surprisingly common on the exam. Routine maintenance usually starts with just replacing the toner cartridge, but eventually you're going to need a full maintenance kit. That replaces those worn-out rubber pickup rollers and that critical fuser assembly we just talked about. After you install new parts, you absolutely must calibrate the printer to ensure everything aligns perfectly, and then clean the system to remove any residual dust. Finally, let's look at a very specific wireless peripheral connection, NFC, or Near-Field Communication. You need to be able to easily distinguish this from Wi-Fi or Bluetooth. NFC is an extremely short-range wireless technology. We are literally talking just a couple of inches here. It's the exact technology that powers Apple Pay, Google Wallet, and those tap-to-pay credit card readers. It's perfectly designed for quick, secure, proximity-based connections. Which brings us to the end of our physical hardware journey, and it really leaves us with a fascinating question to ponder. We've seen how CompTIA is shifting its focus toward ARM mobility and cloud virtualization. With the rapid rise of integrated AI PCs and cloud desktops doing all the heavy lifting remotely, will mastering the physical anatomy of a traditional desktop motherboard soon become a lost art,
Or will the demand for hands-on, physical hardware troubleshooting simply evolve into totally new form factors? Honestly, it's an incredibly exciting time to enter the IT field. So keep studying these physical foundations, trust your troubleshooting instincts, and go conquer the rest of your certification journey.